Okay, so we want to make sure we read through this and we're understanding the scenario. And a few things to look out for in this particular prompt as we're looking at it is that it does tell us that all of this is approximately normally distributed. And, obviously it breaks down how we get the team time. So just some things to look out for. There's going to be little details like this hidden in the prompt, this approximately normally distributed, because if these were not, then all the analysis we're about to do wouldn't work, but they are all approximately normally distributed. And in certain problems, you're going to need to look for whether it says that it was a random sample. And it's somewhere in there, you're probably going to find the phrase that there is a random sample done, not for this prompt, but for other prompts. And we'll try and see that in the future. Okay. So runner 3, so now we've got this scenario down. Runner 3 thinks he can run a mile in less than 4.2 minutes in the next race. Is this likely to happen? Okay, knowing that these are normally distributed race times that have created this, we are going to consider this a normal model. And here is maybe the key thing, and I'm going to keep coming back to this over and over again today, that when you've got a normal model, in this case it's 4.5 and 0.14, you're going to want to draw a drawing. You're going to want to create a diagram for that. And the diagram, of course, is just going to be a normal model. And I'm going to stretch this out a little bit. So in the middle, you have your mean. And your mean is 4.5. And then you're going to have your standard deviations. So up from here, it's going to be 4.64. Maybe if I want one more standard deviation, that would be 4.78. All right, don't need to go beyond that up in the, this is slower times this way. So of course, we're worried about this runner going faster, which should be on the other end. So this would be 4.36. Another standard deviation over would be 4.22. And then one more standard deviation over about right here would be 4.08. And remember, I'm just taking the standard deviation and subtracting it from the mean as we move left and right, or adding it to it. Okay. So we want to have a model drawn like this, the actual normal model, say what model we're using for this. And then we can figure this out. We want to show on the diagram at 4.22, I know I didn't give myself a lot of space right here, but sorry, that's not the right spot. 4.22 lives right around here. Sorry, 4.20. So why do we care about 4.20? Because that is the time that we're interested in for this problem. This runner thinks he might be able to run in 4.2 minutes. And we want to find the probability of getting that time or faster, which means we want to get the area under the curve going this way. So this one diagram right here, what it tells me as a grader is that this person understands that it's a normal model. They understand what X value here is of interest, the 4.2, and where it lives on this particular model, and what part of the area they're trying to find. So we can already tell right from the beginning that this is going to be a very small area. We don't know the exact number. We're going to calculate that. But as a grader, and I am grading you guys, as a grader, this tells me I know this person knows what part of the area they're trying to find, and the area corresponds to the probability that this is going to happen. Okay, so now the other thing that I'm going to be looking for, and that AP would be looking for, it'd be always really good, is to show how you're finding your z-score. And if you want to put even the generic formula just to show, hey, I know what values need to go in here, and I'm going to do the substitution. So my X right here is 4.2. My mean is 4.5. And the standard deviation of interest is 0.14. So showing the generic formula right here without substitution, and then showing the substitution is just very clearly demonstrating that you know what you're doing. And it's all about clear communication, because you're not sitting there talking to the person grading your test. So you need to communicate through your work and through your writing that you know what you're doing. Okay, so now we can of course calculate the z-score, which I got as negative 2.143. Okay, so the next part is your normal CDF. Now you would do that on the calculator. It is worth it to go ahead and write out what you're gonna do on your calculator. Normal CDF of, just happened right here. Oh, sorry. My screen just went weird on my end, but it doesn't affect you guys. All right. Normal CDF, and now we're going from negative infinity, you can just put negative 99, to negative 2.143 with your standardized normal model of 0 and 1. Now, this is a key thing. This on its own is insufficient. If you showed this and you said, this is my calculation, therefore this is my work, that is insufficient to show a grader that you know what you're doing. Okay, maybe you do, maybe you don't, but you're not communicating very clearly, and calculator speak really isn't sufficient. So we've been using calculator speak, especially with like our binomial PDF and CDF, but we need to provide some context. And so we'll talk about that a little bit more. Okay, and for this, in this case, this stuff up here is the context that makes this calculator speak right here make sense. All right. So now I do the actual normal CDF. So today isn't so much how do we find the answer, even though we are doing that, but it's going to be, you know, how do we show our answer? So this equals 0.016. All right, and then we want to wrap all this up because again, this is just a number. We're not answering the question by doing this. We answer the question by answering the question, by explaining. So the written explanation just needs to be kind of put it back into context. The work kind of did a lot of the explanation for us. So we can say right here, there is a 1.6% chance of runner 3 racing faster or running a mile in 4.2 minutes or less. All right. Now, I would look at this, I would see, you know, all the work, the very clear demonstration that you know what you're doing. And, you know, I'm not sure what other kind of explanation you'd need to include with that. This to me looks like, and the way that they do it is with an E, P, or an I. A C means it is essentially correct, which is basically saying, yeah, you got it right. P is partially correct, and I is incorrect. So you want these E's. All right. So now we don't need to read, for the next two problems, we won't need to read the context. We'll just need to have access to this table. The distribution of possible team times is approximately normal, okay? What are the mean and standard deviation of this distribution? All right, so keep in mind that what we've got up here, these are random variables. This is random variable, actually, I don't want it to be X. I want it to be W, X, Y, and Z. Of course, we could have just called it like R sub 1, R sub 2, but whatever. W, X, Y, and Z. These are random variables. We don't know how they're going to end up, but we know the possible values they could take. And so now we want to combine these together. So I want to figure out W plus X plus Y plus Z. And actually, I'm going to erase this. I'm going to do my work starting up above to make sure I have room to do all this. So obviously, I wouldn't put my work here, but it's good enough. W plus X plus Y plus Z, those are combining random variables. So for the mean, the mean of W plus X plus Y plus Z is going to equal, and this is where it really goes a long way to illustrate your thinking. I know that this is the mean of W. Yes, it's time consuming writing this out, but you only have one chance to show that you know what you're doing to the person grading your AP test. So you're going to have to just take the time to write this out. So the mean of all this added together is the mean of each individual random variable added together. And now we can show this. It's going to be 4.9 plus 4.7 plus 4.5 plus 4.8. And those values, of course, I got right here. So we can do that real quick. And did I do this right? So is that 18.9? Is that what you guys are getting? All right. All right, so assuming that's correct, there we go. 18.9 is the mean of all the runners added together. But now we need to find the standard deviation of W plus X plus Y plus Z. And this is where we show that we know the rules of combining random variables. And when we are finding standard deviation, you should know we're combining the variances. And yes, we want to actually write out that I'm going to add the variance for X. I'm going to add the variance for Y. And I forgot W. So I'll just put that in there. The variance of W and the variance of Z. So showing the generic formula, that's a Y, I don't know, I just screwed this up right here. So let me write it again. So there we go. Now we actually can plug our numbers in, and remember the variance can be found, the standard deviations are right here. So now I want to just plug those numbers in, so it's going to be 0.15 squared plus, and I'll just go through 0.16 squared plus 0.14 squared plus 0.15 squared. Now I've already done this math in the previous class, and just because you know how to do this, I'm going to skip to the answer. The answer here is 0.30. You can, of course, I encourage you to do this on your own. I'm just going to move ahead though. So now I might not want to write W plus X plus Y plus Z every time. Maybe you could say the team time, but this really goes to show that we know what we're doing. Now we've created a new normal model. So our normal model, and I'll write it over here, is 18.9 and 0.30. Okay, so now, of course, I found the standard deviation and the mean, but just to reinforce it, it's good to write a sentence. So the mean and standard deviation, or the mean of, and this is where you might take a second to think about how you want to phrase it. I'm doing this quickly. So the combined team time mean is 18.9, and this is where you add the units back in, 18.9 minutes with a standard deviation of 0.30 minutes. All right, so that sentence right there just shows that you understand how this applies in the context. So this little note right here, how it's approximately normal, is when you combine normally distributed random variables together, it creates a approximately normally distributed combination. But now we want to figure out this last question. Suppose the team's best time to date is 18.4 minutes. So that's going to be an important value here. That'll be kind of the X value that we're testing. What is the probability that the team will beat its own best time in the next race? So now this is where I want to draw my normal distribution, but now I'm working with the normal model that I already had it written above, but I'll just write it again, 18.9, 0.30. So now I can just show this 18.9. And when I go down 1 standard deviation from there, didn't quite put it in the right spot. Remember, it's at that inflection point right here. It's going to be 18.6. I'm down at the bottom of my iPad, so it's hard to write. And this is going to be 19.2. I'm not going to worry about going up from there, but down from there is 18.3. Okay. So now we want to figure out where 18.4 lives on this normal distribution, and it's going to be right about here. So I want to find the probability of getting that value, that extreme of a value, or lower. So reinforcing the idea, drawing a diagram with this on it right here, including the normal model that you're using, is going to go a long way toward convincing the reader that you know what it is that you're doing for this problem. All right. So now, of course, I want to calculate a z-score for that. Again, x minus the mean divided by the standard deviation. I've already identified what my x value is. It's 18.4. So this is basically the same thing as the very first problem we did, but we had to create our model before we could solve this problem. And that's what we did in part B. 18.4 minus the mean, which is 18.9, divided by 0.30. Gives me negative 1.6 repeating. So I'll just go 667 right here. And that's going to be good enough for our purposes. And now, of course, I can write something to the effect, since I've shown this work already to show that I know what I'm doing. So these two parts with the normal model drawn and filled in with the area that we're going to be solving for. And I found the z-score for that particular x value. So now I can show the normal CDF. This is not sufficient on its own, just to repeat myself, but it is sufficient if you've got some other work shown. It's good to give this. All right. Now this is going to equal some value. I'll do the calculation real quick. And that is 0.0478. I'll just go to 3 significant digits there. All right, and again, just to wrap it up, we want to have a sentence. And the sentence here, I barely have room to write, so I'll just do the best I can. There. It really is a 4.78% chance of the team time being 18.4 minutes or lower. 18.4 minutes. Oh, I'm not even really have room to write here. Minutes or lower. Oh, I barely fit that in somehow. All right. My stylus doesn't like to write when it gets close to the edge of the screen. All right, we've got a sentence, we've wrapped it up, we've shown all our work, and the key thing today was not how do we solve these problems. The key thing today was how do we show our work. And that's the takeaway for today. All right, now the problems I'm going to give you guys for homework tonight, and again, it's not something you're going to turn in. You're going to grade yourself on these FRQs tomorrow based on what AP is looking for. The, you know, the FRQs are not going to look like this exactly. I mean, you probably would imagine that. So real quick, let me share. Let me get it pulled up real quick. All right, sorry. I'll share this screen now. Okay, I've already got this pulled up, but let me go back to the modules real quick. I'll show you where to find today's class. It's not under like unit 6 or 7 or anything like that. Right here where it says midterm exam, you can see just below the midterm is your October 12th class. And so you would click on that. You can see right here your instructions. Just work on these tonight, do it on a separate sheet of paper, and then look over them. We're gonna look over them tomorrow. So you can just pull up these previews here, or you can download them to your iPad, whatever you wanna do. These are problems related to random variables and normal distributions, so that there will be an opportunity for you to create a normal distribution for all these, I believe. And yeah, that should be true. And here's part 2. This one has 3 parts to it. This one has 3 parts to it as well. I will say, just from my own perspective, this one right here, you're gonna need to take a little bit of time reading the scenario before you jump into the questions, because you really need to understand what it is that's going on. Okay, so bottom line, please work on those tonight. We're gonna look at the grading rubric for these tomorrow, and you're gonna grade your own work. And anyways, that's all I've got for you today. So please work on that tonight.